page 4 of functions. Number 7, a special application measures a person and records on a graph its variation from 37 degrees Celsius, considered to be the average optimum temperature. The application stops working when the temperature of the person is optimum. Okay. So basically might take a little bit of thinking, but these numbers here on the right side are how many degrees centigrade you are above 37. So like 1 would mean 38 degrees Celsius, for example. Okay. And of course the x-axis is time, as it often is. A, state whether or not the relation represented in the graph is a function, giving the reason for your answer. Well, when you have a continuous graph like this, the easiest way to think about it is the vertical line test. So if you do vertical lines all over this graph and you only cut the graph 0 times or 1 time in any place, then you know it is a function. So yes, a function. Yes, function. And it's because a vertical line test passes. Okay. You could also say it's a many to 1, but I think that in the case of a graph, it's easier to say that it is vertical line tested. Okay, you drew vertical lines and it only crossed the function 1 or 0 times. State the domain and the range. Explain their meaning in the context of the problem. Okay, so domain are the valid x values, and you have to include all the values in the case of a continuous graph in between. So you can't just say, oh, 0, 0.2, 0.4. You have to say, starting with the smallest value and going to the largest value and all the numbers in between. So for the domain, we'll say that it's between 0 and 2, and we'll use x for the domain. And we also include 0 and 2 because it does have a point at 0 and 2, right? And then it says explain their meaning in the context. And so basically this is the time. So they basically measured the temperature for 2 hours. So it would be like, you know, they started at 0 hours and they went to 2 hours in measuring. Okay, and then what about the range? So the range would be the valid y values. So let's take a look at the valid y values. The valid y values range from 0 to 4.5. Oh, wait a second, it doesn't go up to 4.5, does it? This is tricky when they provide more y values than actually are present on the graph. If you look at the graph, there is a value as low as 0, and there is a value as high as 4, but there is no value as high as 4.5. And you know, don't just look at the endpoints, because the endpoint here is 3, but you can see that there is a piece of the function which goes above 3, and you need to look at the maximum point to see if that is indeed like the highest possible y value. So for the range, it ranges from 0 to 4, right? And it includes the values of 0 and 4 because there is a point exactly at y equals 4, and there is a point exactly at y equals 0. So we'll put that. And what does the range correspond to? It corresponds to degrees Celsius above, 37. Okay? All right. B. Oh, we already did B. C. Write down the missing coordinates for each ordered pair from the graph. Okay, so let's take a look at these x values they're giving us. They give us, I say x values, but actually t, right? T values. 0.2 is the first value they give us, which is this one here. That corresponds to this point here. You can't really see exactly what it is, so you have to do your best. It looks like maybe it would be like 3.6, so I'm going to put 3.6. 0.8 corresponds to this one here. It's slightly lower than 3. Maybe I'll say 2.9. Oh, this one here, they give us the y value instead of giving the x value. So the y value of 2 corresponds to this point here, which looks like it's about 1.5. And here they give us t equals 2, or x equals 2. I should say t, right? Which is this point here, and it corresponds to a y value of 0. Actually, I keep saying Y, but actually here they use the symbol V. Remember in the investigation when we talked about, replace X and Y with letters that are more related to your context, and in this case, the Y corresponds to the word variation, and the x-axis corresponds to time, right? State the temperature of the person at the start of the application. So of course the start is right there, and so the temperature at this time, it looks like it's slightly above 3. No, it is 3. So it's 3, but remember V is 3, but it asks for the temperature of the person, so you really need to do 37 plus 3 because it's the variation from 37, so that would be 40. After how many hours was the temperature of this person equal to 37? Okay, so it starts out at 40, right? And it goes up, and then it comes back down again, and finally it gets back to V equals 0 here. And remember, V equals 0, you add that value to 37 because this is a variation from 37. So it actually returns to 37 at T equals 2, right? So 2 hours. During which period of time did the temperature of the person increase? Over what period did it decrease? Okay, so here what I'm going to do is I'm going to use the green to indicate the periods where the curve was increasing, and I'll use the red to show the periods where the curve was decreasing. So basically you can kind of see that, I wouldn't call these slopes because you can't really apply a slope to a curve, but it is analogous to a slope. When you look at the green part, it's kind of like a positive slope. When you look at the red part, it's kind of like a negative slope, except it's curved, right? So the period of time where the temperature of the person increased is the part that's under the green section, which looks like it goes from 0 to about, I would say 0.5, okay, 0 to 0.5. So I'm going to put that. I'm going to put that the period of time, oops, I changed to red. Come on. Okay. The period of time where the curve was increasing was between 0 and 0.5. And I will include 0 and 0.5 in that. And then, so this is increasing. And then decreasing would be the red part. So that would be starting at 0.5 and go all the way to 2. So I will put 0.5 less than or equal to t is less than or equal to 2. And you could put decreasing. You might look at that and say, oh, but it can't be increasing and decreasing at 0.5. It has to be one or the other. So if you want to, you could put both less than, or you could put less than or equal to 1 and less than the other. But that's not going to be an issue in our class. I mean, theoretically, we're going to talk about this later in the calculus unit, but when you get to the point t equals 0.5, you are momentarily neither increasing or decreasing. You're kind of at a 0 point. So if you want to, you don't have to include 0.5, but that won't be counted wrong on the exam. Okay. During which period of time did okay, we already talked about that, so we're done with that one. Okay. So now we're on this, blurb here. It says, for a function f, the notation y equals f of x means that x, an element of the domain, the input, is mapped through the function f to y, an element of the range, the output. And we talked about all these keywords here during the investigation. We talked about how f is both a process, which changes an x to a y, and it also is equivalent to a representation of y. We talked about how x is an element of the domain, and it's also referred to as the input. And we also talked about how y is an element of the range, and it's also called the output. Okay? And the way we say it is not fx, it's f of x. And that's important for when you do videos and things like that, but on an exam you never actually say it, so not a big deal. If y equals f of x, then x is said to be the independent variable and y is the dependent variable. We talked about that too, didn't we? Okay, and different variables and names can be used for functions such as, and then here, remember we talked about how the fact that maybe you have different letters to represent x and y instead of just x and y. Okay. All right. And oh yeah, we talked about this too. When, right after you hear this, I don't think people make this mistake, but I've seen many advanced math students freak out when they see f parentheses x and something being done to it on the exams, and then they revert back to their lizard brain and they think that that means f times x, and it's not. Okay? All right. So, number one, a function T of D gives the average daily temperature T in degrees Celsius of a certain city during last January in terms of D, the day of the month. And this sounds maybe a little bit overwhelming, but they're just trying to give you context for this. They're telling us that the T means temperature, so the output value is temperature. The input value is D, which is day of the month of January. And they just say that the temperature is in degrees Celsius and D is in terms of days. Okay. Explain the meaning of T of 2 equals 25. This would be T of 2. So basically we know that the 2 is inside the parentheses, and that corresponds to D. So D must be 2. And 25 is equal to big T, which means it's a temperature. So if you wanted to put that in the sentence, which is, basically what you're saying is D equals 2 and big T equals 25, you can say something like, on January 2nd, temperature is 25°C. The important part of that statement is that there's a connection between January 2nd and the temperature 25°C. That's when the temperature happened, right? State the domain of the function T. Okay, so this is a problem where you don't have the graph and you are doing it from some other information providing format. And let's see. Let's do it from the context. So the domain, remember, is the days in January, right? So what are the possible days in January? So the domain would be, D is an element, and remember, it can't be January 1.5. So it's just the integers. So you can't do an interval where you say, oh, if D is between 1 and the 31st of January. You can't do that because that would include decimals, and we don't want decimals. So we need to say D is an element of the set, and then you put 1, 2, 3, and then you would put ... and then you would put, the last couple numbers, 30, 31, and the ... is a convenient way of saying, oh, all the integers in between, because you can see from the first 3 numbers that my pattern is integers. Okay, so that is how you would say the domain in the easiest way possible. There's other, maybe more advanced math ways to do it, but I'm not going to show you that here. Like, you could use an inequality in combination with the number set. But I think that the easiest way to do it is what I did there. And so the range in this case is, it doesn't ask us for the range. Okay. So that's the domain. Okay. And then C, it says, given the data in the table on T of D, estimate a reasonable range. Oh, now I'm asking for the range. Okay. So it's saying, look at the sample data here for temperature, and then use that to say what the possible values could be. And even though there are no decimals here, temperature is something that could be decimal. It could be 26.5 or whatever. So it wouldn't be wrong to answer this, I think, with an interval, but we could talk about doing it the other way also. So let's say that this is January, and it's a certain city, and it seems like the city is like Campinas or something, because look, I mean, the temperature in Celsius is quite high for January if it was, a northern hemisphere city that's not, tropical. So it looks like the lowest possible value is 20 and the highest possible value is 28. but maybe we don't want to be so restrictive that if there's a particularly cold day, we don't want to eliminate that. So we could do something, like maybe we could put like 40 as the maximum temperature, and then we could put maybe like, I don't know, 15 as the minimum temperature, and then that would give us enough temperatures that are that will probably cover every single possible day in January. If you want to put slightly lower and slightly higher for the minimum maximum, that would be fine. And then you could put like this, okay, to complete the interval. So this would be giving a definition of the range. Okay, and then if you would like to instead define it as, but this thermometer, it only reads whole numbers, then you could say something instead, like you could say, T is an element of the set, and then you could say 15, 16, 17, dot, and then you finish it off with 39, 40, and that would like limit it to integer values instead. Okay? All right. Let's go to the next page. But that'll be the next video. Bye.